Hello guys, Benji here with my second edition of programming tutorials from noob to programmer. And last time we was here we looked at this. I promised we would look at types, and that is exactly what we are going to do. A type is essentially a way of looking at a load of data. They are all stored in the same way in your computer system, but when you run them in your program, it reads it in a different way. A character, for example, can read like that. A short will read like that. Integer, like that. And these like that. Now, the key thing is that a character is a 1 byte integer type, but when used for output to the screen or such, it is represented as a actual letter or system mark, I suppose. System markup. A short is a 2 byte integer type, and an int is a standard 4 byte integer type. They can all be used in integer mathematics perfectly fine, and can be transferred from one to another very well. You can very easily. So just gotta jot those down. A float is a 4 byte decimal point. It's called a floating point, and it can have decimals. So that would be a perfectly fine floating point, as would it be on the double, but a double can be much longer because it is 8 bytes. Now this is interesting because all these will fit onto a 32-bit system perfectly fine. However, the double takes up 64-bit of memory, so well, I don't really know what that means. But be careful if you ever need to go messing about with the bytes and bits of things. This is what they all mean. And if you are not running by the same C or C++ standards, then there is a way of finding out how much something stands for, and that's by using the size of. I think size of is preprocessor, i.e. the size of float will be completely replaced by the number 4, and size of car will be completely replaced by the number 1, unless you're working with something else or you're using different types or whatever. But that will not be able to be read or changed during runtime. Here's a few things you need to know, a bit of terminology. Runtime and compile time are the two main parts of a program. Compile time is when you hit F7 and you get all this big log at the bottom, which in my personal experience just tells me a load of mumbo jumbo crap and not an actual reason why something's not working. Runtime is when you finish the program, you hit compile. Hey? Okay, that is interesting. For some reason it's still open in the background. But runtime is when you've hit compile and your program is successfully exported, and you go to open it up however you need to do so. There we go, it's just finished. And while this message is being printed to the screen, I know it's insanely fast and it seems like it's done instantly, but there is a time while it's working. While that message is being printed to the screen, you're in runtime. While the application is working and it's turned on, you are in runtime. Okay, that did close down properly that time. Don't know what. And there's two main types of bugs in a system. Well, I suppose three main types. Your compile time error, your runtime error, and runtime bug. Compile time errors simply won't let you compile the program. There's something wrong with the source code and it just won't work. Runtime errors, it's again something that's wrong with the program, but it wasn't quite spotted by the compiler. All the syntax was correct and all your programming's fine, but maybe you've gone into a bit of data which doesn't belong to your program and Windows isn't allowing you. Or maybe you're trying to open a file what doesn't exist. You have to make sure you do these checks in your program to prevent runtime errors. And the other thing is runtime bug, where you've not quite written something right, it's syntactically correct, but the actual process of what you're doing isn't right. For example, you want to count up to 100 by adding 1 each time, you're accidentally adding 2, so it only counts. Well, it counts up to 100, but it only loops 50 times. Yeah, that would be a runtime bug, but it's not an error. Things will still work, but not as they're supposed to. So, now that we've looked at the types char, short, int, float, and long, what do they actually mean? What do they do? How can you use them? Say for example I want to create an integer type. To create types or functions, you have to specify what the type is, so like integer, and then a name to store it under. I'm going to go I1, or actually no, tutorial variable 1. Oops. You can have any letter, any valid letter in your name, underscores, and numbers, as long as it doesn't start with that, in your variable names. You also cannot have type names or reserved keywords, that's the word. You can't have keywords in your name. For example, I can't have an integer and call it short, because that wouldn't compile. So I've got an integer called that, and I'm going to set it up to the number 4. You'll see where variables come in here. I'm spelling something wrong. Oh yeah, 1. Let me just remove that. So if I now compile this, we'll say variables are designed as a way of passing information around the computer system. And that's the whole point of a computer program. You pass information around, do things with this information, tell your system to do a couple of instructions. That's all computer programming is. However, most of the time you do it on a much larger scale. So there we go. I've replaced the hello world in brackets, and now it's just got the number 4, which this is the name of the variable I created, and this variable is set to number 4. If I want to change the variable later, I type its name, equals, and a new value, let's call it 7. Damn it, can't type it all. And I can output, oh damn it, I really can't type when it's dark. Output the result again to show that this change works here. This will be changed after we've seen it the first time. Ooh. If I just clear the screen and run the program again, we'll see it outputs 4. There's a variable. New line 7, which is outputted here, and a new line there. And that's the basics of setting up a variable. You need type, variable name, and this bit is actually optional for most cases, except for classes, but that's really advanced for now. If I wanted to, I could remove that 4 there. Oops, I need to keep the semicolon. However, this would not work now, because this up here is just a load of junk on the system memory. We do not know what this is at all. It's considered dangerous to leave it unknown, so whether you do it in the top bit or whether you do it after a while, you know, say we can have loads of other gobbledygook here, you must give it a value before using it somewhere. So I think that covers basics, without me even explaining them yet, of variables. To to declare a variable, it must have a type and a name. Defining a variable is what happens when you give it a value, something to hold, something to represent, a piece of information to actually pass across. That's what the definition of a variable is. And then you can use this wherever you like. The handiest thing, I can't help but feel, oh yes. Now there are other things you can do with variables. For example, I could, you can do arithmetic. So I can do plus, tutorial variable equals 2 plus 7, and tutorial variable equals tutorial minus 5. It can use itself to take 5 away from itself. There's this here gets shortened first to 9, and then that is set to 9. And if we add this here, this gets shortened to 9 minus 5, which coincidentally is 4 again, and that gets set to 4. There is a shorthand method for this minus and plus from the original variable, which is the name of the variable you're editing, the operation such as minus, plus, divide, times and modulus, followed by an equal sign, and the value what you want to edit it by. So this here would, because it's gone through all this sets it to 4, this would be 4 plus 13 and set it to itself. So it's saying get this variable here which is 4 and add 13. Plus equals means add 13, not just set to. I must explain that as well. In maths, equals means the same as a test statement. In programming, it's called an assignment statement or assignment operator, and it edits things. It sets one to another. It doesn't compare them. I suppose it's a good topic to cover next lesson, comparisons, so I'll leave you with that. And good luck, because I think I am pretty useless at this, so if you've kept with me so far, then bless you.